Those are some ideas about how to begin building your program, about how to start thinking from a high level and translating those ideas into things that are actually going to run inside the computer. The next thing I'll describe is the idea of understanding what's actually happening when you run your code. And that's building the mental model of what your code is doing and also what it represents at each step of the program. The challenge when creating any computer program, but especially when you're a beginner, is understanding which parts of the system are responsible for which behaviors. This is an ongoing challenge to educate yourself about how all the different components of the system interact, and it's a job that you never finish with. When you're writing and running code, your ideal goal should be a complete mental model of how the program runs in the system. This probably isn't actually possible for any modern computer system, but especially within the bounds of this course, you should have a relatively good idea of what all the mechanics are for the code that you did actually write. This process of creating this mental model comes in three parts. The first is to state the hypothesis about how you think your code works. And you already have some hypothesis about this because you already wrote the code. So the idea is to be able to explicitly state exactly how you think the code should be running. The second part of the process is to be able to test that hypothesis. So it's possible for you to go wrong here and test the hypothesis wrongly and come to a false conclusion. But the idea is that you want to be explicit as possible in the test itself and understand what outcome you want that test to have before you run it. And the last part is to be able to verify against what you thought was going to happen versus what you actually saw happen. And you need to be able to look at the results and think about your hypothesis very exactly and make sure that they either match up or they don't. This last part of the process is very important because it actually doesn't matter whether or not you were right or not. What's valuable is that if you were right or wrong, this is your chance to either solidify or reinterpret your mental model. And this is where a lot of the valuable learning about how a system actually runs is going to happen. Another aspect of being able to create these hypotheses and test them is that you want to have your focus on that piece of code be relatively narrow, which means that as you're building these mental models, you want to have in mind that one part of the system and to verify that one part of the system and not have to worry about the 20 lines before or after. Which also means that as you're building the code, you want to be constantly running it, and the feedback loop of creating and testing these hypotheses need to be very immediate. So you want to have the strategy of being able to write code and run it very quickly. So if you've been working for more than 10 or 20 minutes writing any code, then you've already waited too long for you to run it. Your strategy around the kinds of hypotheses you need to test and the parts of the code you need to build should be geared towards writing the smallest amount of code possible so that you can immediately run it. Your goal for any program that you write should be that you understand each part of the code that you put into your program. And that doesn't mean that you need to understand it at every single level within the system, but just how the logical construction of what you put together works within the program that you created. As you write more and more code, the ability to keep all of it in your head is going to become more and more difficult. You need a strategy for being able to understand small parts of the code and then immediately ignore other parts. One of the main strategies for this is functions and well-named functions. The idea that we can abstract away or contain certain actions of the program inside a function that's named well is going to help you understand the part that you're working on and ignore the parts that you think are working well. Let's take the example of the dice roll function and the fact that we have these three different math operations. And every time that I use the dice roll function or try to understand what my code is doing around the dice function, I don't need to think about math.floor or what specific operations are going on inside the dice roll function. I can simply assume that it works properly. If we take a look at this code where the dice roll function has been integrated back into the main function, then we can see that the code is just a little bit harder to read. It's a little bit harder to parse out which operations are happening within this whole main function. Let's talk about some specific JavaScript syntax you can write that's going to help you test your hypotheses. And this is just a simple console log, but the strategy behind it is very important. So you want to have a specific reason why you want to look at a value. You want to have a hypothesis as to either why it's a certain value or why it's not a certain value. And you want to have a conclusion about why you think you might be right or wrong. So you could, for example, console log a Boolean expression, just a simple string that tells you whether or not a block of code is running inside a control flow, or just to check a value. And the other important strategy here is that when you look at the console log, that you're able to clearly identify the values that you're putting out. So if that's strings or Boolean expressions, labeling each console log is going to be very helpful. Otherwise, they're all going to blend together.